In this video, we're going to talk about London dispersion forces and how they affect boiling points in organic chemistry. So if we have two atoms that are next to one another, both of them are going to have a net positive charge in their nucleus because that's where the protons are. And then in the electron cloud, they're going to have their electrons. And so that's what they look like when they are nonpolar. Now, electrons, they like to move in random directions. So what can sometimes happen is that temporarily the electrons can all go to one side of the atom. So, for example, in this case, we have a lot of electrons which have gone to the left side, and then not a lot of them that have gone to the right side as a result of the random motion of electrons. So what this does is that when you look at the net charges, there's going to be a net negative charge on the left and a net positive charge on the right. Now you still have negative charges, you still have electrons on the right side, but compared to the left side, it's positive. So this is called a dipole, and the atom is now polarized. However, this is a temporary dipole. This lasts a very short amount of time. And so when you have this type of atom that is temporarily polarized next to another nonpolar, what can happen is that the net positive charge on the right side can attract the electrons to the left. And so this atom can become polarized as well. The electrons will move to the left, and now you have two polarized atoms. And so for this temporary moment, these two atoms are going to feel a force toward one another. Now, the atom that is to the left is called, let me delete these, is called a temporary dipole because it is temporarily polarized as a result of the movement of electrons. And then the one on the right is called an induced dipole because the dipole in it was created by the positive charge that was pulling the electrons from the other atom. And so the force that is created between the two atoms temporarily the force is called London dispersion forces. Now sometimes they're also called van der Waals forces. They exist in all molecules, but they are the predominant force that exists in nonpolar molecules. Now, you need to understand a concept called polarizability, which measures how easily the electrons in an atom are polarized by the random motion of the electrons. So if we take the example of fluorine has 9 electrons and iodine has 53 electrons. Which one of them would be more easily polarizable? The answer is that iodine is going to be more easily polarizable. So the more electrons an atom has, the more easily it can be polarized, and therefore the stronger the London dispersion forces are. So now let's take the halogens as examples. Say we have fluorine. These are all diatomic, so they're going to be in pairs of 2. And let's take iodine as well. The boiling point of fluorine is -188 Celsius, and it has 9 electrons. The boiling point of chlorine is -34 Celsius. For bromine, it's 59. And for iodine, it's 114. Now, chlorine has 17 electrons. Bromine has 35. And iodine has 53. So you just add 8 electrons each step. But the important thing is that the more electrons the atoms in a nonpolar molecule are going to have, the higher the boiling point is going to be. As you can see, boiling point increases as you go down, so the number of electrons. That is because the electrons, since there are more of them, they are more easily polarizable, and the London dispersion forces are stronger, so the London dispersion forces are preventing the boiling from happening, so you need more temperature to actually boil that substance. And so another factor that is important in this is also the molar mass. So I'm going to write the molar mass of these on the left side. So for fluorine, it's going to be 38. Chlorine is 70.9, 159.8 for bromine, and then 253.8 for iodine. So you need to understand this relationship right here, which is the more electrons there are, the more molar mass or weight there is. The London dispersion forces are going to be stronger, and therefore the boiling point is going to be higher. So now let's take this concept and apply it to a practice problem. Let's say we are asked to rank these 4 organic compounds in terms of their boiling points. So first we have methane, which has 1 carbon and 4 hydrogens. Then we have ethane, which has 2 carbons, 6 hydrogens. And then we have propane, 3 carbons, 8 hydrogens. And then we have butane, which is 4 carbons, 10 hydrogens. Now in this case, as we move down, we are going to have a heavier molecule because we have more atoms of each type, both carbon and hydrogen. So we already know that this butane on the bottom is going to be heavier in terms of its molar mass than all the other ones. So therefore, it's going to have the higher boiling point. Now, this you can only do, or at least you can only be sure that this is always the case, when you have non-polar molecules. So whenever you have carbon and hydrogen, and those are the only atoms that are in your molecule, it's always going to be non-polar, and so the boiling point is going to depend on the number of atoms that you have, and because the number of atoms are going to increase the mass. So that's the video. I hope it was helpful. Thank you for watching.